All right. Sorry, guys. I think there was some issue, so my stream got disconnected. So we'll run it again. Very good morning to everyone who is joining. Very quickly, I'll cover the agenda of this stream and what we are going to cover. So, like before I even begin, so let me introduce myself. My name is Prateek Singh. I'm a founder of Ganak.ai. Uh, I was working for LinkedIn for almost 5 years. I have total 13 years of experience. I've written a couple of books. I write a weekly AI newsletter. Created a couple of courses, and I have been writing a lot on multiple platforms to start with. But currently, what I'm doing is I'm building a solution, an AI SaaS application, which is called Ganak.ai. One second. Yeah. So I'm building this AI SaaS application, which is called Ganak.ai, which is an AI SaaS app for generating automated cloud architecture diagrams. And this is not only limited to cloud diagrams. You can basically switch between IAC and cloud and generate diagrams and architectural insight out of everything. So on a very high level, this is what it can do. But it also has kind of an AI integration. So basically, you can select specific resources, add them to chat, and ask to explain and things like that. So all such things you can actually perform on this AI SaaS app. We are going to start releasing the beta very soon, but you guys can go and take a look on the site itself. So yeah, so this is what I'm working on currently, and let's quickly cover the agenda of this live stream. So today we are going to cover what is the anatomy of an AI code editing or coding assistant. We'll cover some basic primer around it, like how it works, what are the integral parts of an AI code assistant, and then we are going to look into kind of like take a like a 10,000 feet overview, a bird's eye view of how GitHub Copilot works in VS Code. And then we'll actually do some debugging in the recently open source VS Code, GitHub Copilot for VS Code. And we'll see how each of these functions actually work in real life. And then we'll end up with some key learnings and references. All the site, whatever you can see on my screen, the slide deck and everything is accessible on bit.ly/Prateek Talks, and you can go and very easily get the slide deck. You can also find all the references which I'm going to be mentioning here on this URL. So with that, we'll quickly switch to this screen, and we are going to talk about the anatomy of an AI coding assistant. So to begin with, like any coding assistant has to start with the user itself. Uh, we are the users, and we basically use some kind of an AI code editor. So in this case, we can take example of VS Code, but in general, this could be anything. It could be Cursor, it could be Cloud Code, it could be Gemini CLI, it could be any CLI or IDE version of AI coding assistant. Just for sake of example, we are taking VS Code here. So you basically write your code here. You basically from GitHub, you'll clone a repository onto your local machine. And once you have your code ready, what you do usually is you ask a question. So you will probably select a piece of code and then you will say, hey, can you please explain me this code sample or this example or this section of code? What happens under the hood is there is a lightweight agent sitting on our local machine itself. So this lightweight agent makes sure that whatever question you are asking, is kind of wrapped in a conversation. So there is a back and forth multi-turn conversation happening, and orchestration of all those conversation, user messages, the AI message and everything that would be taken care by this lightweight AI assistant, which is sitting on top of your machine. Once your message is basically wrapped into a conversation. There are some basic things and checks and IDs attached. It is authenticated and everything. It goes through a process which is called context engineering. So this is our second step, where it goes through a process called context engineering. So any conversation will have some kind of history. You have to retrieve some information from previous memory. So gathering all the context around the conversation which is happening or the question is called context engineering. So context engineering could be some recent memory. It could be recent history. It could be a long-term history. It could be episodic memory. It could be anything which helps your AI coding assistant to answer your query in a much more better and appropriate way. This whole process is called context engineering. So on a very high level, context engineering is putting the right pieces, the right bits of information in your prompt so that your AI system can answer it properly. All right. So once the context engineering part is done, the history, the chat history from the user and from the bot is captured, and any like if you have a database for memory, it is also pulled into the context. And once we have the entire context, whatever tools we want to use and everything, then we pass it this context to a prompt. So what happens is there will be a huge prompt. All your context will go inside this prompt, and on top of it there would be some system instructions. So there would be some system instructions. System instructions are nothing but underlying instructions to the LLM, and that can also include some kinds of safety rules, frameworks, identity, and all those things. So combination of system instructions and the prompt which came from the context engineering plus your user query basically is fed to the LLM itself, and this is our third step. So once the LLM receives the information, it has to answer your query, but it cannot answer your query until unless it understands the whole context of what you're asking. So maybe you're asking a specific portion of the code, but it has to understand the large scheme, overall what is happening into your code base. So there is another process which happens asynchronously whenever you clone a GitHub repository on your machine, or you can have a local index as well. So whatever the code base, document, symbol you have on your local machine, you can basically the moment you clone it or moment you start using it in the AI code editor, what happens is it is broken down into small chunks. So these small chunks are basically fed to an index databases. So basically it goes through a model. So there is a model sitting in between. So we can call it an embedding model. So this embedding model, once that your documents and your code base goes through, it generates a long series of integers. So something like 1, 2, 3, -4. It could be anything. Like it's usually a very long, highly dimensional data, which is an actual mathematical representation of your code itself. In our case, it's code, but in various cases, embeddings can be either from image or either it could be text or anything, even for the videos. But on a very high level, your code base goes through an embedding model, and then embeddings is generated, and this embedding is saved into a vector database or an index database. So whenever it is stored into the database or index, what happens it becomes very easy to search from this database itself. So whenever you have a code, you want to query something or something which is related to the code section, you can very easily retrieve that. So one of my earlier live stream, I think the first one, I kind of went deep into how embedding works, how similarity works, what is the cosine similarity, angle, and how similar semantically similar meanings are retrieved from vector database. For example, I'm asking a question about some API, and there is some library which is used in those APIs. Once it is fed into through by creating embeddings, it is fed into a vector database. You can easily correlate between what code chunks are interrelated and easily retrieve that. And once you retrieve that, you should be able to get a proper context itself inside your prompt and basically pass it to the LLM so that it has the full understanding of your code base. So I'll encourage you to go and check my first live stream, which was on retrieval augmented generation, where I covered what vector databases, indexing, how RAG works. It will kind of like connect the dots for you to understand how this part will work. Uh, yeah. So once it understands and fetches the relevant code from the index database into your curated system instruction and prompt which was created, it basically now the LLM is basically able to answer your query. So based on the context, based on your user query, based on the entire embeddings of your code base, it is able to answer your queries, and this query is as a response streamed back to the front end. So this becomes like our fourth step, and this is the final streaming. This is the fifth step. So overall, this is the entire loop which happens. And now, since it came back and streamed back to your IDE, you kind of basically accept, reject, or do some tweaking, and based on your changes, it goes back into a feedback loop, and this loops basically repeats multiple times. And if it is an agent, it might go autonomously do a certain steps in an autonomous way, and you don't have to like manually approve or reject specific piece of code. So on a very high level, this is an anatomy of an AI coding assistant. With this, we'll quickly switch some gears and go and see like how it works in GitHub Copilot itself. So for that, let me just quickly switch my screen here. And I kind of already covered this anatomy of an AI coding assistant through that diagram, but we'll look into this one, which is how GitHub Copilot works. So on a very high level, like we kind of understood in our anatomy itself, there are three major pillars in GitHub Copilot architecture. So first and the most important pillar is the Copilot extension itself. So which is an extension sitting on top of your VS Code on your local machine. And it kind of does the work of that lightweight agent which we were talking about, creates a conversation, does the authentication, authorization, streaming, and all those stuff which is required to be done on your local machine. Then there is a middleware which is called GitHub Copilot Proxy, which is on cloud, which sits in between your local extension and the backend LLM. So why this sits in between? Because GitHub might have indexed your repositories already. So it has that index DB, that vector DB, where your portions of your code can be fetched very quickly. Since it is a middleware, it can also act as an authenticator. It can do rate limiting. It can do a lot of safety checks. We can introduce a lot of filters on top of it. So it can go through multiple layers of filtering so that there is uh, no malicious activity which is going on, or no adult content or anything which we are just kind of any racist remark we are passing. So that can be filtered across through this middleware, which is GitHub Copilot Proxy. And then finally, the backend LLM itself, which is uh, the final piece where once your code base and everything captured and your user query with a curated prompt goes to an LLM provider. In our case, we have mentioned OpenAI LLM, but on a very high level, this could be any LLM provider. So let's quickly look into this sequence diagram. So first two sections, what you see is on a local machine. So this is the first piece of the architecture. User enters a prompt, and this prompt basically the intent is detected on this prompt. It gathers local context. So what kind of tools I have locally? Can I fetch the files? Can I check other files are there in workspaces? Then a prompt is created basically, and a JSON payload is created to do an API call. So with your prompt and everything, we'll see that how that works in real life as well. So big JSON payload is built with your prompt, some system instructions, what API endpoint to call, how many tokens I can use, and all those things. And then this is encrypted and sent over HTTPS to the GitHub Copilot proxy. So once it is received there, it does some validations. It sanitizes your payload, and obviously does a lot of telemetry and maybe like for enforcing some policies as well. And once everything is done, it kind of fetched your GitHub repos code as well if required from an index DB. It basically forwards that prompt or context to an LLM. So once the LLM returns a response, again the same steps are trickled down, and finally user gets the response back onto their IDE. So this is on a very high level how it works. These are like three main pillars, three main layers on like how GitHub Copilot works. And with this, I'll switch to my VS Code editor, where we'll see how this actually works by debugging step by step to see how each of these steps will actually look like. So with this, I'll switch my screens. So what do you guys see on the screen right now? This is my GitHub Copilot in VS Code Insights, which is running. So on the right hand side, you see this GitHub Copilot chat window. On bottom icon, if you see on this bottom icon is the GitHub Copilot, which is running here. And I have this VS Code window where I've opened the open source repository of VS Code Copilot chat, which is nothing but the GitHub Copilot repo itself, which was recently open sourced. So what we are going to do today is we are going to put some breakpoints in this repository and kind of like understand step by step how each of these things work. So in order to run this locally, we already have a session here, but if you run this GitHub Copilot in the same session itself, we won't be able to actually debug it. So what we'll do is we'll go here in the debugging, and there are a couple of options here. So I'll just click on Launch Copilot Extension. So what this will do, the moment I click it, it will create an extension development host. And what it does is whatever the repository was there, if you see whatever the repository was there, it's now open a new window is open where you can test your extension which you are editing in the first VS Code window. So I have this VS Code open source window open here, which you can see on the left hand side, and then you can actually open that extension development host, and whatever the you type in this chat extension right now in this extension development host, that would be debugged in the previous window, the main window which we have. All right, so I have opened a repository here, which is one of the repository where I keep all my presentations. So I've already opened this repository, so which is fine. That doesn't matter. So what I'm going to do now is first talk about what is indexing, right? So we looked into in this diagram earlier that there are a couple of pieces to this, right? So there are a couple of pieces to this. One of the most important pieces were indexing, right? Which is in the sitting in just in the center itself. But how does that work in our use case? So we have this central piece, which is for indexing, but how would that will work in VS Code? So let's first look into how this knowledge, this indexing is created so that GitHub Copilot has a good understanding of our code base. So for this, we are not going to do a deep dive, but basically whenever you come on a GitHub Copilot chat window or in your VS Code, on the bottom right corner, you see this Copilot icon, right? If you click on this, you'll see there is a workspace index created. So since this repository is cloned from this presentation repository is here, this is the repository which we have. This is a repo. And since this repo is already cloned on from GitHub, it's already present in GitHub itself. That indexing is already taken care for us. So that is already in GitHub backend, and that part is already taken care. So the moment I clone this repo, you will see that workspace index would be remotely indexed, right? So that means that index is already created for us. But if I just go ahead and create a new repository, 1 second, let me open a new window and we'll go open, we'll go to workspace, go to repo, And we'll go to, let's take this test repo. Right. So this is not is right now I've not initialized it with Git, or I've not pushed it to GitHub. So if I click on the GitHub Copilot here, you see it's locally indexed. So if the repo is not there on GitHub, it will kind of create a local cache, a local index of your code base. I tried to find where that index file is, but I couldn't find a relevant documentation on Microsoft where that index file is. But that is kind of not part of this demo as well. But if I find that, I'll kind of share that it later as well. But the whole story is whenever you clone a repository from GitHub itself, since it is called GitHub Copilot for VS Code. The moment you clone anything from GitHub, that repository already has a remote index created on GitHub, and your VS Code will understand and fetch relevant pieces of code or embeddings to kind of create an appropriate response for you. So that is was something which I wanted to quickly cover regarding the indexing part. Now, what we'll do is we'll quickly kind of minimize this and we'll go back here and I'll show you some of the breakpoints I've set up. So I've set up a couple of breakpoints here. If you want to really see what these breakpoints are or kind of understand, go to that presentation, github.com Pratik Kumar Singh / presentation. I'll just quickly open this QR code. So if you want to just quickly scan this, stop the video and quickly scan this QR code, it will take you to this repository. And what you can do is you can just go to the 10th folder uh, in the presentations on how GitHub Copilot works. And if you go to images, and there is a screenshot for the debugger breakpoints. So you just set the same debugger breakpoints in your VS Code Copilot chat and debug it, and you will be able to do the same things which we are going to do right now. All right, so with this, let's actually run the GitHub Copilot in the extension development host environment and see what we get. So I'm here already. Uh, Let me just close this and rerun this. Let's see what happens. And what I'll do is, okay, so I'll select a few more here and I'll just debug it again. Run and debug, and it will open the chat for us. So if you see, the moment it opened the chat for us, I'll just minimize this. So the moment we kind of initiated this chat window here in the extension development host environment, immediately it kind of hit the breakpoint. So what it is doing right now, it is using an API client service in this my local agent which is working, and it's kind of trying to fetch the relevant models which are available. So right now, is so for example in this environment where I'm actually debugging, you see this drop down where all the models are listed, right? But in this one, we don't see the models yet. So right now it is trying to understand what models are available so that it can present appropriate models which we can use in this repository. So I'll just keep on continuing with this and you'll see uh, after a few seconds, you see the model access intent has been identified and it is doing an API call, sending a payload to get the model. So it's trying to get that list of models. The moment this request is complete, you'll see again in your GitHub Copilot, in the extension development host, the list of models is available now. So this is like a very first step. Make sure all the models are available on your local machine. Then once we have the model, I can actually go ahead and ask some questions. So maybe like ask a very basic question like hey. So once I started hey, it's kind of trying to understand my request. So it is going through a series of code blocks where it's trying to understand your intent and trying to filter what is the right appropriate intent for this use case. So if you know in VS Code, you can actually initiate GitHub Copilot from multiple places. So you can actually initiate from your code base, like you can have like open inline chat, and that will also initiate a GitHub Copilot prompt, and you can have this conversation tab open. You can also run it in CLI. So you can do something like this, and you can select a specific portion and also open an inline chat. So there are multiple ways, multiple intents which can happen. And based on your use case and categories, different kind of intent would be detected, and it will go through a different code flow based on your use case. So we are not going to cover every like a flow which is going to happen, but on a very high level, we'll cover a conversational flow, which you see on your right hand side, which is stopped on working because a breakpoint was hit. And we'll try to see if we can do an inline chat as well, just to show you the different intents possible. Right. So I was able to ask it a question, and it is right now stuck on this intent. And if you see, it has all these intents available. If you see on the left hand side, the review intent, the VS Code intent, start debugging intent, and all those kind of things. And I'll just keep on running this. And you see, the moment like the intent was identified, what will happen? It will straight away jump into gathering what tools are available locally. So part of creating context is also identifying what tools are available in my vicinity and using those tools and sending those tools to your LLM so that LLMs can leverage those tools to create a proper answer. So if you see that it will go through an enumeration of tools and kind of keep on looking for what tools are available and gather everything possible. And see, here it was able to capture a certain number of tools. So it shows like what tools are allowed, right? It shows like total 44 tools are identified, and those tools could be apply patch, could be like add some specific code sections, create a directory, create file, do a file search, grep search, and all those kinds of tools are available to this VS Copilot, VS Code Copilot Chat. So these tools are available right now, and what we'll do is we'll keep on hitting next and next again. All right. And now we kind of hit the next couple of times and was able to gather all the tools. And now it is actually stuck on something which is called get instructions. So now it is trying to see what system instructions I have. So there are some hard-coded instructions which are working in background to make sure that overall experience is good, correct information is passed to GitHub Copilot, apart from the user prompt which we can customize. So Microsoft and like it's open source now, so the wonderful engineers across the world are kind of contributing to this piece where they are engineering a better and better system instruction to make sure that GitHub Copilot works properly. So since we're kind of covering the system instruction part, I'll quickly switch to the file explorer and I will actually show how some of these prompts will look like. So I came to this extension as a source repository. Sorry, in the source directory, there's an extension directory. And if you go, there is another one called prompts. And if I go and there is a base repository here. So these are all base prompts, which kind of act as a system instruction, which are kind of fed to your AI agent on top of the custom instructions which you give as a prompt. So let's see what things are available here. So first of all, let's see what is this. This is the identity prompt. So if you see, there's something like strange way of writing a prompt. So far we have written prompts like how we like it, how we write it in ChatGPT. Like we kind of write a text, but this is kind of enclosed in some kind of like XML tags. So what is this? So I'll talk about this more. This is something called prompt TSX. So this is pseudo XML style of writing a prompt. And once I cover the references part at the end of this session, I'll give you all these links to go ahead and uh, uh, refer what prompt TSX is. On a very high level, this is a declarative way of defining a prompt in a pseudo XML style prompting. It kind of allows you to create modular prompts and basically treat prompt as a first level first class citizens of software engineering, and don't treat prompts like something like a text, a huge text. Treat it like a software unit, and then only you would be able to uh, leverage this and create a better and better AI agents. So the whole idea of prompt TSX is to make it more modular, more pluggable, more composable, and this is how it is allowed. So you can create this kind of a pseudo XML style prompts, and this specific prompt is for Copilot identity rules, so that Copilot can understand who am I. So it is telling when asked about your name, you must respond with GitHub Copilot, follow users requirement carefully to the letter. So it's basically telling what who you are to the prompt. So if in case I go ahead and ask, hey, what is your name? So it knows that my identity is this. So this is one instruction, right? And for GPT-5, it is a little different, right? So depending on the so since there are two identity prompts, you can kind of do conditional rendering also, right? One like if the model is GPT-5, we'll probably render the second one. We'll not render the top one. So based on that, we'll kind of modularize the prompt itself so that it can be rendered accordingly. Similarly, there are some safety rules. Again, like GPT-5 has some safety rules, avoid content that violates copyrights, and if asked about harmful, hateful, racist, sexist questions, basically say that sorry, I can't assist you with that, and keep the answer short and impersonal. So that kind of thing is available. And then again, like different types of prompts for different use cases, a lot of instructions are happening there. Go ahead and check it out, I'll suggest. And here is the prompt which generates the capability. If somebody asks what are the things you can do, it kind of understand that these are my capabilities. The prompt is you can answer a general programming question and perform following tasks. And all these command descriptions are passed so that the model it understand what are my capabilities and what are the things I can do. So in a such way, prompts are basically in a modelized way composed and constructed, and it has allows us to do conditional rendering and based on use cases, specific scenarios, render a specific type of prompt, making sure that only relevant bits are curated in the context. Not everything is done. So one brute force way could have been we just write a very big prompt that. If this is GPT-5, do this. If GPT 4.1, do this. But that is not a good way because we kind of consume a lot of tokens and we don't want to do that, right? So we only want things to be passed to the prompt which are actually necessarily required, and we don't want to overburden the model with too much information. Right, and then we'll model will hallucinate and we'll say that it's not working. So we have to engineer our context properly, and this prompt TSX library allows us to do that. Right. So yeah, so on a very high level, this is what prompt TSX is. And with that, I'll quickly jump back to where we were. We were talking about, one second, I'll go to debug. We were talking about how specific things will work, right, in the agent prompt and how the instructions are retrieved. So this particular section will go and retrieve the instruction. And if you see, there's something interesting happening here on the left hand side in the variables. It shows what is the token budget. Okay. It is telling me the token budget and what is this token budget. So let's actually look into what this token budget is. Right. So I search budget here in this code section, and if you see, it is kind of giving me a few things here. And if you come here, budget, there was a formula. Let me hit next. Yeah, so this is the one. So now if I scroll a little bit up, you'll see there is some calculation happening. There is some base budget which is defined, and how this is defined is there is a configuration service for each of the model. Every model endpoint will have a max prompt token limit, and that is the base budget which is allowed, right? So ideally, if you throw away a lot of information in the prompt itself, it will kind of eh, like uh, like it would be more than the prompt token window allowed. So we don't want to do that. So we first of all define the base budget, which is the allowed number of tokens which can be passed to in a prompt to a model, and then we kind of do a safe calculation of safe budget. We kind of do how many tools are available. So we're not only sending the prompts itself, we are collating a lot of internal tools, like local tools. So for example, on the left hand side, you see all these tools, right? So these tool definitions and what they can do, their input schema, their name and everything also consume some token. So we are kind of reducing that from the base token and calculating a safe budget, which is allowed for that API call, the prompt to happen. So this intelligence is kind of also very necessary if you are building an AI code agents, so that they automatically, based on the model, identify what is the safe token budget available and only use that. Otherwise, it will kind of lose the information and we won't be able to get a proper answer out of it. So once you have actually calculated the safe budget and everything, you capture other things as well. You get the endpoint, which you have to call, you get the last message. So we basically type some messages here. So all the messages is here available in this prompt. And if you see, all the tools are also captured, right? So this is basically the whole prompt which is built. So it has tools, it has my user queries, it has the endpoints, the base budget and everything which is passed. And if I click on next, 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 there is a list of tools which is returned by tool enumeration. And now it will again go to the Copilot API client service. And now what is happening? It has identified the intent as conversation agent. Why conversation agent? Because this is the agent which is running in this conversational window. And that is why it was able to identify a conversation agent. And with this, it's creating an HTTPS request with the post method. There's a timeout and about signal, all those things given. There's a secret key which is passed. There's a telemetry service also initialized here, and there is a body. So in the body, there we have the model name, we have all the tools, the temperature we have picked in, and whatever the messages we are going to be passing here would be available here. So, right, so all these messages are here. I'll click on next, and that API call will happen. And we'll wait for a few seconds here. You see, you got a response here, right? So this is on a very high level, how an intent is identified on a local machine, how a conversation is created with a multi-turn responses, how token budget is calculated on your agent which is sitting on your machine, and then there is a context engineered kind of capturing all relevant tools available in your local vicinity, then finding out what is your base token budgets, finding out what models are available, and then passing all this information in a big prompt, a curated prompt to the Copilot APIs with the model name, and it kind of gives back you the response. So this is like one way of kind of reaching to the Copilot and giving you a response. But there is another piece which we kind of missed is the streaming portion of like like kind of receiving the response itself. So what we'll do is we'll kind of click on it's kind of still working. So what I'll do is also enable something called in the breakpoints, something which is called chat ML fetcher. So this is basically something which intercepts the streaming endpoint. So let me just enable that breakpoint and click on next. And it is going through iteration again, right? So it is building the prompt again, capturing all the relevant tools. The conversational API call is still happening and and working. Yeah. And now the stream was intercepted. So now you see on the screen it is still working. So usually what happens as a best practice, usually models will respond a little sort of slower, right? So there is a two-way like a two-step network flow where like a request goes to the LLM and kind of comes back. And usually models will give a very big response and they kind of predict tokens one at a time. So either you have to wait for 10 seconds to get an entire response, but the best user experience would be like streaming the chunks as and when they are created to the front end so that the user experience, the time to see, the time to token is much faster so that while the user is reading what the response he or she is getting, they can actually on the back end is actually getting generated as well. So it's a good user experience for the user. There's kind of a limitation with the LLM, so we kind of with this UX we kind of overcome that limitation. So if I just keep running this, you'll see I'll just move it here, right? I'll just keep running this. And so you see there like the text has been captured and it is getting captured delta by delta, like token by token. And after certain amount of buffer is reached, that message would be start streaming in the front end. So here on the left hand side in this debugging window in the variables we see, I'll insert the explanatory doc strings and inline comments. And here you see I'll has already been streamed to the front end. And I think as we go along, we keep on like proceeding with the next steps. You see the more and more tokens are getting you're getting on the front end on the right hand side. So this is how things are streamed back to you and you get a response, right? So I'll just disable this ML fetchers because that was something which I wanted to show you and it will just immediately show you all the response which it was able to fetch, right? So I'll stop this and yeah, I'll stop this and probably restart the debugging session. And we kind of covered end to end how a request is constructed on the front end itself in the ID and how it is how the all the relevant tools, information, and prompt system instructions are captured and sent through an HTTP call to Copilot API. How Copilot API generates the response through an LLM, which is sitting behind the Copilot API, and how the chunks are streamed to the front end, and we get a conversational response in the front end itself. But this is one type of agent. But if you look into the agents which are available in VS Code Copilot Chat, there are multiple agents which are available. Uh, they are not only the agents which are available for conversation. You can actually have agents and prompts for inline edits or terminal uh, questions and all those things. So it's kind of a multi-agent framework where different agents and different prompts have serve kind of a different use cases. So that is the whole intent of having a multi-agent kind of an architecture, which is being used here. So with this, now we'll quickly look into a different agent inside. So we kind of looked into conversational agent. Let's see what happens if we do an inline edit and what kind of intent is detected and what kind of response is generated. Right. So for this also, I have this very small implementation of Fast API. So I'm basically using Python to create some very basic to-do APIs. And I'll simply do what is I'll right click on this. I select it, right click on this and click on open inline chat and I have this ask a question window here. So I'll ask a question here. Create docs of these API endpoints as comments. And let's hit it. And before I hit it, let me check if I have. Let's launch this thing again. So the window is running. It's again running. I'll quickly just complete everything so that we have a fresh window. All right. So I'll add a comment again, open inline chat, add docs for these endpoints as comments. Right. So before I hit it, let me check if I have all the relevant. Do, 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 do. Yeah, I have entered so inline chat. So this is the file I'm looking for, inline chat edit code prompt. So this is a specific prompt which is used in case of an inline code edit. And you can actually look into this prompt as well, but I'll hit uh, this one, and it immediately goes to the Copilot endpoint. And if you see there is a conversation inline intent automatically detected. Right. So depending on your use case, different intents would be detected, and based on your intent, based on from where you are calling the Copilot, a different prompt would be weaved in together in your context and basically serve you for that particular use case. So I'll quickly click on next. Again, goes back and identify intents. Right. And it is going and on. Yeah. And it kind of went and created a response for you. So this is on a very high level how different intents can be detected from like based on from where you are calling the agent, and it will give you a different response. And if you look into one of these, like in one of these prompts, right? And if you see the prompt of what it is, so you are an AI programming assistant. When asked for your name, you response with this, blah, blah, blah. And there are some legacy safety rules, which is again, this is a prompt TSX uh, component. We just use kind of embed this, and it will just embed the actual text which is behind the prompt here. You can just do like a single enclosing of this uh, sudo XML tag, and it will just embed the prompt here itself. So this basically becomes a system message, and then it has all the information. So it has instructions like source code is always contained in these blocks, and the user need help with the has code without selection and all those things. So whatever you have selected and everything, this is passed to this prompt, and this goes as a system instruction with your history and previous messages and everything, and kind of helps you generate the prompt. So one of the beauty, one of the very good aspects of beautiful aspect of prompt TSX is also the priority and the flex grow feature. So what you can do is basically since there are limited number of tokens, what you can do is you can define priority and define like how much you can grow the token window and shrink it, right? So if it has more token budget available and it can actually embed more context, it will actually grow and embed that in your prompt. So it can be automatically managed based on whatever the priorities and flex store rules you select here. And you don't have to manage everything or on your own or write code for that. So that is like a batteries attached way of actually creating a dynamic prompt with some priorities and some flex grow properties. And if you see sibling elements will be rendered first, followed by this element, and the remaining token budget from the container will be distributed among the elements with the flex growth. So whatever will have flex growth, the budget will be distributed accordingly. So you can define things like that, and this is like one of the nicest thing which I found in uh, prompt TSX, which is very useful and friendly. So on a very high level, this is how your GitHub Copilot work. We kind of like went into different stages, how the agent locally works, what are different important pieces, which weave in together to give you a good experience from like a prompt TSX pseudo XML based uh, prompt curation, conditional rendering of prompts, and creating the curated prompt, which can be like basically the required bits of information which can be sent to to an LLM, and then we also saw like how the conversations are tracked locally, and how it is like kind of how the API calls are curated, and you kind of gather all the relevant tools which are available locally, and all this information is passed to a middle tier. That middle tier will kind of like relay that to the LLM, and LLM will return a response in form of streamed chunks. And these streamed chunks are actually one token at a time stream to the front end so that you get a good user experience. So this is a very high level how it works. I hope you kind of got what I was trying to show you guys. With this, we'll close up with some of the key learnings and takeaways from this session. So first and most important thing is context is your superpower. Not only like it's important to have some kind of indexing. So it's a GitHub repo, it would be auto indexed. Then there needs to be sometimes some local indexes as well. Uh, the idea of creating a better and better context is having the minimal information required that can help you to create better and better answers. So there will be some patterns which if you dig deep, there would be like summarization, trimming, pruning of the context so that only relevant information is passed. And the better the context is engineered, the better responses you'll get out of your AI agents. Second thing is prompts are software. So treat prompt as a first class citizen of software engineering. So make sure your prompts are declarative, that you can do conditional rendering, they are composable, use TSX, JSX, whatever, so that you can clearly differentiate between system instructions, user instructions, and since you're treating it as a software, you can also have Git versioning. You can see the diff and everything. You can track what changes you did. You can do evals of, if, for example, I changed these few lines and now the eval scores are up and down. So that is much easier to track. So treat prompts as software units. That would be really helpful if you're building agents and especially AI code editors. Uh, Layered, we also looked into layered instruction strategy. So we kind of looked into safety rules, we kind of looked into identity, format, task, and predictable outputs. So there is a layer of different kind of prompts which kind of help you get to the point where you want to get. So basically, it helps you to reach the goal you want to reach with all these layers prompts. So we have some safety rules, some instruction which we saw. We saw some identity rules. We didn't see the formatting instruction, but we'll tell like this is how you should define your code, like in the code blocks example we saw, and all those things. Then there is a multi-agent orchestration. So specialized prompts and specialized agents for specific needs. Don't build a general purpose agent for everything. Uh, there is a different agent and prompt for a conversational which is happening. There's a different prompt for intent, like inline edits. So don't build one single generalized agent for everything. Have smaller prompts, specialized niche agents for specific tasks. There has to be also a tool augmented loops. So before even it can do anything, it has to understand what tools are available. So it goes through an enumeration and get all the tools available and kind of feeds that prompt, kind of augments your prompt with all the available tools so that LLM can use those tools and create better and better responses. Then we also talked about the networking and the UX part. Usually, one round trip turn basically is going from your ID to the proxy to the LLM and then coming back usually takes roughly around 10 seconds or something, sometimes for bigger responses. But to reduce this round trip time and make sure that token to value or first time to first token is much lesser. We kind of do streaming of chunks so that users can start seeing responses on their screen in first few seconds of prompting, and they don't have to wait for entire 10-15 seconds for the answer to populate. Right. So this is one user experience strategy which we can leverage. Then there is a security and compliance things. We saw some safety rules, some identities, and there are review gates which are happening so that there is no misses in terms of racist remarks, any kind of compliance, malicious activities, and only give least privileged tools access. So whenever you are also enumerating locally on the number of tools which are available, don't just give every tool to the model itself. If it is running autonomously, you can have like least privilege model applied to it so that model can only run things which are required to be run. Right. So these are some of the key learnings which we have. With this, I'll quickly switch to the references section. So I'll encourage you to go and actually read about it. How why and how prompt TXS was created, what is the philosophy behind it. So there are some good blog posts available here. Go and check this out. This is a very nice video which I found on how GitHub Copilot works. Go and check this video out. This is from GitHub itself. It's really nice sketch and doodling. If you're really interested, it hardly takes two minutes for this small video. but it will give you a high level context how everything works. And then there is a life of prompt, how basically uh, prompts are basically constructed, how every bits and pieces are put together and then sent to, and what are the different layers, which we talked about, three different layers which are available. And you can read about more that. And then there are some nice blogs on anatomy of AI code assistants, open source AI coding assistant that will help you out and kind of help you in understanding what these things are. Right. So with this one last piece, which I want to very quickly cover, if you want to do a similar research on any topic or kind of understand any open source GitHub repository, I want to show you two things, right? First of all, there is a repo to text tool available on Hugging Face if you want. If you just paste any GitHub URL. So let's take this one itself. You come here, you just type the any URL, GitHub repo URL you have. If it is a private repository, just pass the personal access token and you just fetch the directory. And once you have the directory, if you have, for example, I have a lot of these files I'm not interested into, I'll just unselect everything. And I'll quickly move to one of my recent demos. And what I can do here is like all of these are the Python files. I'll just quickly select all these Python files, right? And I can create generate text. So why I'm showing you this is usually when you are trying to understand a repository, ideally you manually go and read about that repository. But there are a couple of ways how you can very quickly learn or debug or understand what a repository or a code base is doing under the hoods is first of all fetching all the directory structure. Just copy this directory structure from here, and now it is available to you and which you can feed it to any prompt. So your any of the LLMs, if you just feed this prompt, it will understand what file structure is there, what is the code in each of these files, and it should be able to very easily give you a response and kind of give you a high level summary or targeted questions would be answered based on that. So that is one quick way of getting information. Second way, you just clone this repository in VS Code itself, and once it is cloned, you can start asking questions. So GitHub Copilot in VS Code would be able to answer all these queries for you without an issue. So that is the second approach. But for very complex use cases or very big repositories, what I also do sometimes, which I find it very useful, is I use either deep research on Perplexity, or I also do like an agent. Uh, I use GPT-5 agents and kind of give a super prompt to it. So, for example, if you see, I created a super prompt here where I have given the task for deep analysis of this open source repository since the code is open source. And some objectives like what I want, what patterns I'm looking for. I'm looking for architecture flows. I'm looking for frameworks and toolings. That's why I discovered prompt TSX. I am also looking like context engineering, what formats responses I'm looking. So this kind of super prompt you can create and pass it to GPT-5 agent, and it should be able to generate a very neat response for you. And that would be very elaborate, will take 10-15 seconds to generate a response for you, but that would be very elaborate. It will have links to your repository as well. And if you're interested in this super prompt, it is again available on my presentation uh, um, repository. Just go to 10th directory, which is how GitHub Copilot works. There is a super prompt available. Just use this prompt, feed it to your GPT-5, and you will be having like a good understanding of any repository you want to learn about. Right. All right. So with this, guys, thank you everyone. That's all I have for today. But let's keep this conversation going. Here are some credentials which I have. If you want to scan and give me a quick follow on one of uh, my company's Ganak AI Labs. So company page, or just give me a follow. If you have any questions, feel free to drop a message, tag me on any post. I'll be always happy to answer your any of your queries. Connect with me on LinkedIn. I talk about AI, cloud, software engineering, a lot of things. I really love doing that. And I'm building something cool with Ganek.ai, which I'll be sharing very soon more and more about. With this, I'll take your leave. On to the next session, I think I'm going to cover agentic RAG, how to build agentic RAG systems. So I covered RAG already. So if you don't know RAG yet, go and check out my first live stream where I covered how to build RAG systems, which is retrieval augmented generation. But in the next stream, we are going to see how agentic RAG is going to be built, right? So go and check out my first stream, and in the next stream, we'll be looking into agentic RAGs. And till then, see you everyone. Take care, and let me know if you have any questions. Bye.